All right, in this next segment, ha ha ha, pun intended. Okay, of video, we are going to look at some definitions that we're going to use, and they're more contemporary definitions. We're also going to talk about the symbols used for these things, as well as kind of illustrate them, trying to wrap your head around what they look like, okay? So we're going to start with something we already know, and it doesn't have all the components, but the distance from A to B, remember that we just write that as AB, and this is always representative of a number, right? It's a numeric value, okay? We're not going to talk about set theory here. In words, we're going to say this is the numeric distance between the points A and B. Okay, for the illustration, notice there's nothing necessarily there. We could actually have a line going through A and B, or a ray, or an angle, or they can just be 2 points though. We just want to know what the distance is between them, and that's what we are representing by this symbol. Okay, for segment AB, this is what it looks like. We use AB with the straight line over the top of it. That represents the segment AB, okay? And what this means in set theory, this is what it looks like. All x's such that x is between A and B, or x is equal to A, or x is equal to B, okay? Not necessarily really important that you know that, but at least you're exposed to it. See if that makes sense to you. In words, it's the set of all points between A and B, as well as the endpoints A and B. And it looks like this. Here's just a segment. And notice there are points on the ends representing the endpoints. And it's just every single point in between there, as well as those endpoints. Okay, so next we're going to deal with ray AB. And a ray is a funny thing. It's almost like you take a line that goes infinitely in both directions and cut it somewhere. I would say cut it in half, but there's no really half of something that's infinite, right? So when we're talking about one side of a line, it looks like this. So this is ray AB, and that's different than ray BA because it starts at point A and goes through point B. Okay, so whatever letter is used first is called the initial point of the ray. All right, and this kind of indicates the direction. And we always go to the right when we indicate rays. All right, now in set theory, we say that this is the set of all points x such that x is between A and B, that's that segment piece, or so that B is between A and x. So x is collinear to A and B on the other side of B. Or x is equal to the initial point, or x is equal to that point B, okay? So that's in set theory. In words, it's the set of all points that are collinear to A and B that are situated on the side of A that B is located. But then we've got to include the initial point as well. All right, and so this is an illustration of ray AB starting with the initial point A going through B, and now this would be ray BA. Okay, here's their notation. Starts at initial point B and goes through A indefinitely. Okay, the last of these definitions is line AB. It's notated like this. AB in symbolic form with this line with arrows on the ends. With a line, it doesn't matter which order the points are in this notation, right? Because it goes infinitely in both directions. And that's true with a segment too. All right, in set theory, this is going to be all x's such that x is between A and B, or all the x's such that B is between A and X, so on the other side of B, or all the x's such that A is between X and B, so all the x's on the other side of A, or X is equal to A, or X is equal to B. Okay, so that's what it looks like in set theory. In words, this is really easy. It's all the sum of all points that are collinear to A and B include of A and B. And this is what the illustration looks like. In the next video, we're going to talk about segments. We're going to look especially at the ruler postulate, and we're also going to look at the segment construction theorem. Okay, those two things are in the next video. See you then.